All right, let's get into our last objective for the particle behavior unit. This was on the last one. Just a quick review because it ties in with this objective as well. Remember, all changes of state are physical changes. You're going from a solid to a liquid to a gas to liquid to solid. You're changing forms, and it requires either you to gain or lose energy. If you're speeding up the particles to melt something, particles move faster, you need energy. If you're speeding up a liquid till the molecules spread apart and turn into gas, you need energy. And to go the opposite direction, if you have a gas and you want to slow the molecules enough down to they become a liquid, you need to lose some energy. And liquids molecules slow down enough to become a solid, you'll lose energy there as well. The big push in this objective is what's called a phase change diagram that you see here. So we want to look at these in terms of temperature. So if we look over here, the temperature is increasing as we go up in this graph. And what happens to our states of matter? So down here, we start with a solid. Once we reach here, we have a liquid. And then finally over here, we have a gas. All right, so remember, the molecules in a solid are close together. If we give them energy, they start moving faster. So as the temperature goes up, we're still a solid, but those particles are moving faster. This point where we level off here, notice the temperature is not going up. Even though we're heating the substance, it's because that energy is being used to break apart those attractions or those bonds between those molecules. Once they're all broken, we're in liquid mode, we said. We keep adding energy to the liquid. Those molecules speed up, speed up, speed up. We level off here because those molecules, even though we're heating it still, those molecules need extra energy to break the bonds that hold them together. And then eventually, if they're broken apart, we form a gas. Again, the thing you want to add to your notes is what I've said, but it's down here. The temperature remains constant until the change of state is complete. Again, that's why we level off. So you may see a question of what's happening here. What's happening is we need more, the energy is being used to break the attractions or the bonds between the molecules. This one might be a little easier to see, but it's the same exact chart. We start as a solid. As we add heat, the molecules move faster, faster, faster. This is the phase change right here where we're melting because we're using the energy to break the bonds that hold the molecules together. Now we're a liquid. Heat, 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 heat. It levels off as we break the bonds that are holding the molecules of the liquid together, and then we're into a gas again. So we've said this, but we're going to say it a bunch because it's so important. When energy is added, particles move faster and further apart. So let's just start at the bottom with a solid. Remember, all particles are moving, but these are kind of moving back and forth in place. When we heat them up, they get enough energy that they move faster and faster and faster till eventually they can break apart, and now they have a little bit of freedom of movement in the liquid. Heat them again, more and more and more, they have enough energy to break apart even that little attraction, and they're all over the place like a gas. It happens in reverse. If we look starting with a gas, if we cool things down, they slow down until they slow enough where they get stuck together a little bit as a liquid. If we keep cooling them or taking energy away, they'll slow down even more where they're stuck together in place as a solid. Remember last objective, melting is going from a solid to a liquid. So when water gets to 0 degrees Celsius or 32 degrees Fahrenheit, it will change into a liquid. But the key is just reviewing that melting is going from a solid to a liquid, and it adds energy. Freezing is the opposite. It's going from a liquid to a solid, so in this case, we lose energy. Vaporization or evaporation is, we said, going from a liquid to a gas. That means we need to add energy because the molecules are faster in a gas, so we have to speed up those molecules in a liquid, and we're talking again about this top part here. Condensation would be the opposite. We're going from a gas to a liquid, so we're slowing the molecules down, so we need to lose some energy. We'll look specifically here with water for our phase change. The graph is the same shape. You might have a longer rise or shorter rise, different depending on the molecule, but the shape's always going to be the same. You heat it, the temperature goes up, and then it levels off. Remember, it's leveling off while we break these connections or bonds or attractions. And once they're broken, now we can move around a little. We're a liquid. So in here, we're a liquid. We heat it, heat it, heat it. This long break here is so we can break these attractions between these molecules until they have the freedom to move every which way as a gas. Make sure on your quiz that you know how to read those phase change diagrams. I put one in the note guide for you. Know that there's evidence you can look for, like if you see bubbles forming, that means a gas is being made. Well, when would a gas be made? In evaporation, when we go from liquid to gas. When we add energy, molecules move faster. If we add enough energy, they move fast enough to change state. And the opposite's true. When we lose energy, molecules slow down. If they slow down enough, they change state there as well. As always, after you take your notes and watch this video, do your practice quiz until you understand the questions really well, and then take your real